So lateral earth pressure is a pressure exerted by backfill. Pressure exerted by backfill against retaining wall. So it is predominantly in horizontal direction. Now you can see. This is the figure. Retaining wall. Now let us discuss now. Take some element of soil. Take some element of soil. Element means small piece at a depth z from the ground surface. Now, if you see this element, so let us see now what is the vertical stress and horizontal stress. So let us see now the state of stresses. State of stresses at any point which is located at a depth z. Okay, at a depth z. Now let us discuss now what is sigma v, what is sigma h. Now someone can ask me what is sigma v. Sigma v means vertical stress. As you know, at any depth z, when the soil having unit weight gamma, the unit weight of the soil is gamma. At any depth z, I want vertical stress. Can anyone tell me now? Gamma into z. Gamma into z. Gamma into z. For example, the moment you see how consider a depth here the pressure is gamma into z. Now someone can ask me what is the vertical pressure at the bottom of the wall if the height of the wall is h. H is the height of the wall. H is the height of the wall. Now let us discuss what is the pressure at the base of the wall, gamma into h. If it is 0 here, no doubt at top z is 0, gamma into 0. Now at any depth z, gamma into z. At any depth z is equal to h, that is at the base of the wall, gamma into h. Now our discussion is about vertical stress. But we want horizontal stress. Here this discussion is happening in soil mechanics. Vertical stress, how to calculate effective vertical stress. You know that sigma dash is equal to sigma minus u. Okay, so sigma means total stress. If water table is there, if groundwater table is there, pore water pressure is also there in picture. Pore water pressure. So this is very interesting to know. We know vertical stress. But we need to calculate horizontal stress. So let me tell you, horizontal stress is nothing but here lateral earth pressure. Because in this direction, in horizontal direction, we are getting stress from soil. So this stress is going to be resisted by constructing this retaining wall. Otherwise, if retaining wall is not there, this soil will be slided like anything. Soil will be falls down. So this is what I would like to tell you. We have a retaining wall. So adjacent to retaining wall, we can see backfill. That is nothing but soil mass. So I want to know the state of stresses. At any point. That maybe I would like to call point P, which is located at a depth z from the ground surface. What is the vertical stress? So I know how to calculate vertical stress. Gamma into 0, gamma into z, gamma into h. So vertical stress I can able to calculate. Now let me tell you. So here now horizontal stress. We are designating with sigma h prime. Why I I'm writing prime, you know that why I'm writing prime. Many times if water table is there, we need to consider effective stress, because effective stress is the original stress acting on soil. That's why please keep this point in your mind. We have to concentrate on effective stress. If it is a dry soil, your soil mass is dry, then sigma dash is equal to sigma. So please all of you understand that sigma dash is more sophisticated term. We need to use in place of sigma. Sigma having limited understanding. Sigma dash is the original stress acting on soil. Sigma dash means sigma minus U. What is sigma? Total stress. U means whenever water table is there. For example, if water table is there, then we need to calculate sigma dash. We don't just calculate sigma. But here I see I have considered a dry soil. I consider dry soil. So there is no issue. I can write here gamma D into 0, gamma D into H, gamma D. So now pore water pressure is 0, luckily. So now sigma H dash I need to calculate. Sigma V dash I know. Sigma V dash I know. Sigma V dash I know. This is the variation of vertical stress from top to bottom of behind the retaining wall. Behind the way the vertical stress is distributing, okay, due to its self weight, gamma is self weight. Okay, now horizontal stress we need to calculate. Horizontal stress is equal to K into vertical stress. So in other words, K is equal to sigma H dash by sigma V dash. Now someone can ask me, so what is K? K is a coefficient. K is a coefficient which relates this horizontal and vertical stress. Now K is called coefficient of earth pressure. Coefficient of lateral earth pressure. So K is equal to sigma H by sigma V. Strictly speaking, sigma H dash by sigma V dash. Now someone can ask me, what is coefficient of lateral earth pressure? Coefficient of lateral earth pressure is the ratio of horizontal stress to vertical stress. Horizontal stress to vertical stress. Strictly speaking, effective horizontal stress to effective vertical stress. As you know, sigma dash means effective. I need to write, I will not run. Sigma dash means effective stress. This you studied in your basic geotechnical engineering in the last semester. But I will help you once again. You don't worry. I will teach you how to calculate effective stress. Don't worry now. So now, what is lateral earth pressure? Lateral earth pressure means it is a pressure exerted by backfill against retaining wall in lateral direction. If you want a further understanding, in lateral direction, in horizontal direction. So now, very interesting to know. Here you see, I have pressure. But what is this capital P? I have pressure. What is this capital P? So capital P is force. Capital P is force. So force is equal to area of earth pressure distribution diagram. Earth pressure distribution diagram. I know the earth pressure distribution diagram, you can see here. So I need to calculate the area now. See, because why I am drawing like this in linearly, you know, it is gamma into 0 here, it is gamma into H here, it is gamma into Z here, gamma into H here. Then once we join the extremities, hence we will get linear. So absolute right angle triangle. I can see right how to calculate area of the right angle triangle. Now I can able to calculate now. So now you can see half base into gamma D H into H. But I am looking for lateral force. So if you are looking for lateral force, now what I have to do now? If I want lateral force, what I have to do? Now I need to multiply with K. Now K into gamma D into H into H. Now capital P is equal to K into gamma D H square by 2. This is what I call lateral pressure or force. Can anyone tell me now what we have calculated? Lateral force. So we are using capital P for force. Thrust, also called thrust. Many times we usually use this word THRUST, thrust. So if you want to calculate force, we need to calculate area of the earth. EP means earth pressure, D means distribution diagram. So we need to calculate area of the, it is a right angle triangle. So I can able to calculate of base into height, K gamma D H into H, then I'm getting K gamma H square by 2. K gamma H square by 2. So now with this introduction, I can tell you what is K, what is lateral pressure. So initially, so here you see lateral earth pressure is a pressure exerted by backfill. Backfill means soil mass against the retaining structure. Here the retaining structure is retaining wall in lateral direction. So now this is about lateral earth pressure. So now what is coefficient of earth pressure? Coefficient of lateral earth pressure. K is equal to sigma H by sigma V. But strictly speaking, sigma H prime by sigma V prime. That is correct. Sigma H prime by sigma V prime. So now coefficient of lateral earth pressure is defined as the ratio of effective horizontal stress to effective vertical stress. Now, actually, my interest is not just calculation of pressure. I want to calculate force. If you want to calculate force, you need to calculate area of the pressure distribution diagram. So here I want capital P. I'm not happy with small p. I'm looking further for capital P, which is force. So of base into height. So I am calculating lateral force. That's why you see P in lateral direction, horizontal direction. Now I can see of base into height. So someone can ask me why you are multiplying with K. Because I'm calculating lateral force. That's why I should multiply with K. What is K? Just now we discussed sigma H prime by sigma V prime. This